For the Identity Backwards worksheets, we have an expanded sum difference or double angle formula, and what we want to do is condense that back to the sine, cosine, or tangent of a single quantity. All right. So this one right here mimics the behavior of, if we had cosine u, cosine v, plus sine u, sine v, right? And what is that equal to? Which formula? Cosine of u minus v. All right, so this is mimicking the behavior of the difference formula for cosine. So what we need to do is identify what u and v are equal to. Well, that would be our value of u. This would be our value of v. So this will be equal to the cosine of 10 minus 5, which is obviously the cosine of 5 degrees. So that's our answer. All right. Any questions with that one? Key thing there is to identify that it is the difference formula for cosine. Remember, cosine will be opposite of what the sign is here. So in this case, it is plus, so we know that we will utilize minus. All right. Okay. If we go to number 4, all right, this one alternates. It goes cosine, sine, sine, cosine. And if you look at your angle formulas here, the ones that alternate are for sine, correct? So typically this would go sine u, cosine v, and then sine is the same sign, so that would be minus cosine u, sine v. All right. So the difference here is this is sort of switched up, right? And this is switched up. All right, the order of the sine and the cosine. And it is important with this one that u goes with the sine. So in this case, our value of u would be 5, and our value of v would be 10. Okay? So this is u and this is v. All right? So we can condense this down to the sine. It is the difference formula for sine. So that would be the sine of 5 degrees minus 10 degrees, which is equal to the sine of negative 5 degrees. All right? So you do have to be careful with that particular process. All right? Any questions with that one? What's up? Here? Because in our formula, the first part, u goes with the sine. All right? Yeah. In a bit. All right. Number 7. This mimics the behavior of the double angle formula for sine. Okay? So that's equal to the sine of 2u. Okay? So 2 sine of an angle times the cosine of an angle mimics the behavior of the double angle formula. So in that scenario, our value of u is going to be pi over 5. So this will be equal to the sine of whatever u is, 2 times whatever u is. So u is pi over 5, so that can be simplified to the sine of 2 pi over 5. All right? So that's it. Once you identify what u is, it's just a matter of plugging that value into the original identity and go from there. Okay. All right, if we look at number 10, that looks like a double angle formula for tangent, correct? Okay. So the value of u is pi over 7. All right, and this will be the double angle formula for tangent. So this would be equivalent to the tangent of 2 times pi over 7, which is the tangent of 2 pi over 7. That's it. So it has the structure of the double angle formula for tangent. You identify that the value of u is pi over 7. You plug that in. That's it. So it's just condensing the formula down. All right. A couple things on two that are a little bit more complicated. All right, I'll get you started on those. You are going to skip 11 and 12, correct? Okay, so skip 11 and 12. Cross those out. With this one, the first thing that you want to do is, this is a whole, we don't have an identity that has 6 and 3 involved, but we can factor out a 3. So if we do 6 cosine squared 8 divided by 3, that would give us 2 cosine squared of 8 degrees. And then negative 3 divided by 3 would be minus 1. And then we can now use the double angle formula for cosine to finish that off. All right. So use the double angle formula because that mimics the behavior of the double angle formula for cosine, and that'll give you what you need. All right. For number 14, this 10 is what bothers me. We don't have anything with 10 out in front, but you could rewrite 10 as 5 times 2, right? And then we still have sine 20, cosine 20. And then now we can utilize the double angle formula for sine on that problem. All right? Those videos are posted on the website, so if you didn't get any of that down,